different behaviors here too. One, science! It worked!
It's not magic, it's science.
Welcome back to iScience, coming to you from the iScience studios here at the CEC. I'm your host, Dr. Donald White. Today's experiment is going to be very metal. We're going to burn metal right here in the studio. But before we can do that, we need to talk about chemical reactions, also known as chemical changes. We learn in 5th grade to look for 5 signs of a chemical change. There's color change, bubbling, change in odor, temperature change, and formation of a new material. Some people include burning and light being given off as evidence, but I like to include them with temperature change. Let's take a look at a chemical change we all know. To do that, I'm going to need to go to the void for some supplies. I'm going to need some safety glasses, a candle, a lighter, and a spoon. Safety glasses for safety. Now that I got everything in place, let's jump right in. Remember, anytime you're working with an open flame, you need to get an adult's help just to be safe. When I light the candle, you can tell right away that a chemical change has taken place. We can see that there's light and heat being given off, and there's also a new material being formed. If I hold this spoon over the flame, you can see black stuff forming on the back of it. That's soot. It's wax that hasn't been completely burned. Fun fact, did you know that the wax in the candle has to be turned into a gas before it can burn? The solid wax is warmed by the flame of the burning wick, turns into a liquid, and then it gets pulled up the wick where it gets warmed even further and turns into a gas. Once it's a gas, it'll ignite. I can prove it to you. When I put out the flame, the smoke coming off the candle is gaseous wax. I can actually relight the candle without touching the lighter flame to the wick. When I touch the lighter flame to the smoke, the wax vapor ignites and relights the candle. Let me show you. I know what you're thinking. Big deal. It's a candle. Well, this leads me to our next chemical reaction. To get this going, I'm going to need some more supplies from the void. I'm going to need a scale, a battery, and some steel wool. Now, this reaction is so metal that it's tough to stop once it gets started. So I recommend that you don't try this at home. I'm going to place the steel wool on the scale. You can see its mass is 2.15 grams. Now, when I touch the battery to the steel wool, we'll see a chemical reaction start. There we go. Look at that. We can see several signs of a chemical reaction happening. We've got heat and light being given off. There's a definite odor. There's a color change happening too. Look, you can see the wool getting darker. We can also measure the change in mass. Look how the mass goes up. That's the iron taking in oxygen from the air, making rust or iron oxide. And it's giving off heat and light. This reaction is what scientists call an oxidation reaction. The new substances we're making are iron 3 oxide, which you guys know of as rust, and iron 4 oxide, which is the dark gray material. My 8th grade science friends might want to talk about this reaction in terms of the evidence of a conservation of matter. For my high school friends, maybe you want to talk about balancing the chemical reactions and calculating the percent yield based off the initial mass measurement. I do have another application for you of the same reaction. Photographers and artists use this reaction to paint with light. I'll show you what I mean. This method is extremely dangerous and you shouldn't try it at home. I'm not going to show you how to set it up, just the end results. Well, that's our show. I hope you found the science of chemical reactions as metal as I do. Join us next time for more iScience with Dr. White from the CEC.
This has been an original production for the CEC Network.